In this topic, we're going to discuss about the introduction, number system, and rectangular coordinates. Prior to the year 1600, geometry as developed by the Greeks and algebra as developed by the Hindus, Muslims, and Persians were two completely unrelated mathematical disciplines. They remained so until 1637 when René Descartes, a renowned French mathematician and philosopher, published a treatise called La Géométrie, in which he introduced the concept of coordinate systems. He indicated how, by using coordinates, it was possible to represent geometric configurations by equations and vice versa. This important discovery made it possible to use algebraic or analytic methods in geometry and, as a result, led to the development of a far more comprehensive theory of geometry called analytic geometry. 30 years after the origin of analytic geometry, two other prominent mathematicians, namely Isaac, Sir Isaac Newton and Gottfried Wilhelm Leibniz, developed independently another new and revolutionary idea in mathematics. This new concept dealt with the notion of limits, that is, with a values approached by non-finite sequences of numbers. This theory of limits is the basis for what we call now calculus. The advent of these two significant contributions marks the beginning of modern mathematics. Now let's proceed to the next topic, which is the number system. In analytic geometry and calculus, we are primarily concerned with real numbers. These numbers can be divided into two groups, the rational and irrational. The rational numbers consist of zero, the positive and negative integers, and the numbers which can be written as the quotient of two integers such as 3/4 and negative 3/4. All other real numbers, such as square root of 2 and pi, are called irrational numbers. Remember that division by zero is not defined in mathematics. Thus, the expression 1 over x and cotangent x have no meaning when x is equals to 0. The real numbers can be represented graphically on a straight line by designating an arbitrary point of the line as 0 or the origin and laying off equal divisions in both directions from 0 as what you can see in the illustration. It is customary to locate the positive numbers to the right of 0, and these numbers are 1, 2, 3, 4, and so forth, and the negative numbers to the left side of 0. A scale such as that depicted is called the real continuum. If A and B are any two real numbers, the notation A is less than B, or graphically that A is to the left of B on the real continuum. This same relation can also be written as B is greater than A. Observe in both cases that the inequality sign points the inequality sign points toward the smaller of two numbers. Certain classes of real numbers can be designated by using inequality signs. Thus, x is less than a means all numbers x to the left of a. The notation a less than x and less than b represents all numbers x between a and b, that is, the numbers which are both greater than a and less than b. To represent, please refer to the illustration. To represent the points of the continuum which lie outside the interval from a to b, it is necessary to write two inequalities: x is greater than a or x is lesser than b. Observe that these two inequalities cannot be written together as a is greater than x or greater than b, since this latter expression implies that a is greater than b, which is incorrect. When any line segment is taken in definite sense from one end point to the other, the segment is said to be directed. Now let's proceed to the rectangular coordinates. In order to describe the position of a point in a plane, we form what is called as a system of rectangular or Cartesian coordinates. First, you need to draw a pair of perpendicular reference x and y. These lines divide a plane into four parts, which are called as the quadrants, which are numbered as shown in this illustration. So quadrant 1, these are the positive x and positive y. And then quadrant 2, negative x and positive y. Quadrant 3, these are both negative x and y. Quadrant 4, positive x and negative y. The line x is called the x-axis and the y is called the y-axis, and together they are known as the coordinate axis. This point of intersection 0 is called the origin. The position of any point in a plane can be described by giving its distance from these two axes. To measure such distances, we arbitrarily choose some unit of length and agree that distances measured to the right of the y-axis shall be positive and those to the left shall be negative. Similarly, distances measured upward from the x-axis are positive and those below are negative. Let P represent any point of the plane whose distance from the y-axis is x and whose distance from the x-axis is y. The value x thus obtained is called the abscissa or x-coordinate of the point P, and y is called the ordinate or y-coordinate. Together, these values are called the rectangular coordinates of the point P, and we write them in the form x on y. The position of a point is determined if its coordinates are known. Conversely, if the position of a point is known, its coordinates can be found by measuring its distance from the two axes. The process of locating points when their coordinates are given is called plotting the points. So here's an example. Draw a line connecting the points A with negative 2 and 3, and B is positive 1 and negative 1, and find its length. For the solution, in the notation used for representing points, remember that the first number given is the x-coordinate and that the algebraic signs indicate directions. Starting at the origin to plot the point -2 and 3, we move to the left 2 units and then up 3 units to plot +1, which is x, and -1, which is y. We move 1 unit to the right of the origin and then down 1 unit. After connecting these 2 points with a straight line, we may draw a horizontal and a vertical line as shown in the figure on your screen. Since the triangle thus formed is a right triangle, we can find the length of the hypotenuse by using the following geometric theorem. In any right triangle, the square on the hypotenuse is equal to the sum of the squares on the other two sides. Since the sides of the above triangle are clearly 3 and 4, we have AB is equals to 3 to the power of 2 plus 4 to the power of 2 equals 5. So that ends our lesson for today. So we discussed about the introduction for coordinates and lines, and then the number system and rectangular coordinates.